In this video, we're going to take a look at section 2.4, which is all linear functions. And what we're going to take a look at is graphs and slope. Now, our first objective is to find the slope of a line given 2 points. Let's take a look at the definition. So the slope of a line passing through x1, y1, and x2, y2 is given by m is equal to rise over 1, which means the change in y over the change in x. And then the formula that you're going to be using to find out what the slope is, it's y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So let's take a look at what's going on. Let's take a look at what's going on with the graph so we can see it visually. So let's say we have these 2 points. Let's say this is our x sub 1, y sub 1. And then this point over here is our x sub 2, y sub 2. Okay, so what the slope measures is the steepness of this line. So it's a ratio of the rise over the run. Okay, so this would be x sub 1 over here. This would be x sub 2. This would be y sub 1, this would be y sub 2. So to figure out how much it's rising, to figure out how much this line is rising, you would subtract your y coordinates from those 2 points. So this will give you the rise. Now to see how much you're running over, this is the difference between your x coordinates. This is x sub 2 minus x sub 1. So we have the ratio of rise over run. Okay. So let's take a look at an example here. So we're going to graph the line passing through the given points and find its slope. Okay. So to graph this line, we're already given 2 points. That's all we need to figure out. That's all we need to graph this line. So let's draw a rectangular coordinate system. Okay, so we have the point -1, -1, which is right over here. And then we have the point 2, -4, which is this point. And now we can go ahead and connect them with each other. And then we have our graph. So we have our graph, but now we want to figure out what the slope is. So let's use our formula. We have m. M denotes the slope. So we have m is equal to, so we have y2 minus y1. So over here our y2 is -4. We have minus y1, which is -1, all over, and then we have x2 minus x1, so we have 2 minus -1. And now let's go ahead and simplify. So the minuses become plus, so we have -4 plus 1, all over 2 plus 1. So we get m is equal to -3 over 3, which simplifies into -1. So the slope for this line is -1. Let's take a look at the next one. So we have m is equal to, so y2 minus y1, so we have 1 minus 2, all over x2 minus x1, so all over 3 minus 0. Simplify, so 1 minus 2 gives us -1, all over 3 minus 0, which gives us 3. And now we figured out the slope. But let's take a look at the graph as well. So 0, 2, which is this point over here, and then we have 3, 1, which is right over here. And we could connect our, make that a little bit better, connect the points with each other. And now we have our graph. Let's take a look at another example. Let's start with the graph first. So we have the point 3, -1 over here, and then the point 3, 5. Now if we connect them together, we have this vertical line. So for this particular example, our graph is just a vertical line. Now let's see what happens when we find the slope of this vertical line. So we have m is equal to, so we have 5 minus -1, all over 3 minus 3. So this changes into 5 plus 1 over 0, which gives us 6 over 0. Now, since we have 0 in the denominator, so what this is indicating is 6 divided by 0. Whenever you are dividing by 0, this is undefined. So the slope for this line is actually undefined. And now, as a matter of fact, whenever your slope is undefined, what that indicates is you have a vertical line. Now we're going to take a look at a different way of graphing. We're going to be graphing using the slope and the y-intercept. So the y-intercept, this is the point on the graph where it crosses the y-axis. So we're going to be using that point, and then we're going to use the slope to find one more point. Now when we're using the slope and the y-intercept to graph, what we want to do is get our equation or our function in slope-intercept form. Slope-intercept form is f of x equal to mx plus b, or y is equal to mx plus b. So something that should probably sound familiar. So m is the slope, and then 0b is the y-intercept. Okay, so first example, find the slope and y-intercept of each equation, and then graph. Now, if we take a look at the equation that's given to us, this is already in slope-intercept form. So since it's in slope-intercept form, we can identify the slope and the y-intercept pretty quickly. So our m in this case, the slope, is the number in front of your x. So in our case, we have 1/2. And now our y-intercept, your x-coordinate is 0, and you have -3. Let's go back just a little bit. So let's just say you have a line. So you have any line here. So the point where it crosses the y-axis, so this point right over here, this is your y-intercept. In order for the line to cross the y-axis, your x-coordinate has to be 0. That's the only way it'll cross this y-axis right over here. Your x has to be 0. So that's why in our equation, that's why we have 0b for our y-intercept. So in our example, we have 0 and then -3 is our b. Okay, so now when we graph it, okay, we're going to start with our y-intercept, and then we're going to use our slope to find one more point. So our y-intercept is 0, -3, which is right over here. And now we use the slope to find one more. So remember, slope, it's rise over run. So this is telling us to go up 1 and then to the right 2. So you go up 1 to the right 2, we get this point. Now that we have 2 points, we could go ahead and connect them with each other, and we have our graph. Now, next example, this is also in slope-intercept form, it's just random function notation. But our m here, our slope is -2, it's the number in front of your x, and our y-intercept is 0, 1. This is all the information that we need in order to graph. Okay, so we're going to start off with our y-intercept. We're going to start off with this point right over here, 0, 1. And now we use the slope to find one more point. Now our slope here is just -2. But you could always change this into a fraction by putting a 1 underneath it. You could change any whole number into a fraction by putting a 1 underneath. And now we have a rise over a run. So since our rise is -2, what we're going to do now is go down 2, and then we go to the right 1. So we're going to go down 2, so you go down 1, 2. And then to the right 1 puts us at this point. And now we can connect the 2 points with each other. So just be careful here, because that minus sign, you only attach it to one of those numbers. You either attach it to the top or you attach it to the bottom. Now, if we attached it to the bottom, so if we wrote this as 2 over -1, this is still the same as -2 over 1. It's just in a different form. Now what this tells us to do is to go up 2 and then to the left 1. So if you go up 2 and then to the left one, let me make this one a little bit further out. Okay, so if you go up 2 and to the left one, it puts you at this point, which is still on the line. So you could do it either way. My suggestion is always attach the negative to the top and just leave the bottom number positive. Okay. Now let's take a look at a trickier one. So we have the equation 3x is equal to 2y plus 4. So we want to figure out the slope and the y-intercept, and then we want to graph it. Now the way that this equation is written, it's not in slope-intercept form. So I can't determine what the slope is quite yet. So what I have to do in this case is get the y completely by itself. So I have it in slope-intercept form. And then I can identify my slope and my y-intercept. So let's go ahead and isolate the y. So first we're going to subtract 4 from both sides. We get 3x minus 4 is equal to 2y. And now let's divide both sides by 2. And we get our y by itself. So we get y is equal to, so we have to divide each one of those by 2. So we get 3 over 2x minus 2. So now my slope is 3/2, and my y-intercept is 0, negative 2. And now I have all the information I need to graph. Okay. So start off with the y-intercept, which is 0, negative 2, which is this point. And now our slope is telling us to go, so we have rise over run, it's telling us to go up 3, and then to the right 2, which has put us over here. And now you could go ahead and connect them with each other, and we have the graph of this equation. Okay, now the last objective here is applications involving slope. Okay, so we're given retail sales during a holiday season have grown from 416.4 billion in 2002 to 655.8 billion in 2016. Find the rate of change in holiday sales with respect to time in years. Write a sentence explaining the meaning of the rate of change in context with this problem. Okay. So what we're given over here is actually 2 ordered pairs. We're given 2 points that are on the graph. Okay. So the years, this represents our x coordinates, and then the sales, that represents our y coordinates. Okay. So let's go ahead and write these ordered pairs out. That way we could use the formula and find out our slope, which also indicates the rate of change. So we have 2002 and 416.4 billion. So we have 2002 and 416.4 billion. And then we have 2016 and 655.8. Okay, so we have 2 ordered pairs. So if we want to figure out the rate of change, that's saying the same thing as finding the slope. So let's use our formula. M is equal to, so we have 655.8 minus 416.4 all over 2016 minus 2002. Okay. So now let's go ahead and simplify this. So we're going to go ahead and subtract. So we have the 655.8 minus 416.4. This gives us 239.4 all over, and now 2016 minus 2002. That's going to give us 14. Okay, let's divide. Let's see if this gives us a whole number. So 239.4 divided by 14. So it gives us 17.1. So let's simplify as 17.1 over 1. Okay, so now we have our rate of change. Okay, So now we have to write this, write out what this means with the context of this problem. So we have 17.1 over 1. So the rate of change in holiday sales with respect to time. So holiday sales are increasing 17.1 billion every year. So every year the holiday sales are increasing 17.1 billion. Now that's all that there was in this section. That was it for 2.4. Remember, if you have any questions, don't hesitate, just email me.